Hi there, welcome to your video on how to solve linear systems by elimination. This is the second algebraic method of solving linear systems. The first was the substitution method that you learned last day. This method with elimination tends to be a little bit simpler. In order to use the elimination method, what you have to have are both of your equations in the same format. If you notice, both the x term and the y term are on the left side of the equal sign, and the constant is on the right side of the equal sign. If they weren't both in the same format, you would have to rearrange one of them to be in the same format as the other one. Since they're in the same format, we can begin. So, first, label the equations. This is 1, and this is 2. Then you're going to choose either x or y. It doesn't really matter, but what you'll notice in some questions is choosing x or choosing y would be easier. It's hard to see it in the first example, but in later examples you'll see. So the coefficient of the x term is 6, and the coefficient of this x term is 1. What we want to do is to make those two coefficients exactly the same. The way you do that is to determine the lowest common multiple of their coefficients. So by lowest common multiple, if you look at the 6, the multiples of 6 are 6, 12, 18, etc. And the multiples of 1 are 1, 2, 3, 4, 5, 6, etc. And the lowest multiple that is common to both is 6. Then what you have to do is multiply each equation by whatever number would make the coefficient equal to the lowest common multiple. So the lowest common multiple of the x is 6. So equation 1 already has a coefficient of 6, so we really just multiply equation 1 by 1. Equation 2 has a coefficient of 1. What would you have to multiply this equation to make this a 6? Well, you'd have to multiply it by 6. So we're going to take equation 1 and multiply it by 1, and we're going to take equation 2 and multiply it by 6. When you multiply an equation, you have to multiply all three parts of it. Since we're multiplying the first equation by 1, it doesn't change the equation. It just stays 6x plus 5y equals 32. When we multiply the second equation by 6, it's just like distributive property. Make sure you multiply all parts of the equation by 6. So you get 6x plus 6y equals 84. Now, what can we do to both equations to get rid of that x term? What we can do is subtract the equations to eliminate the x term. So we're going to subtract this entire second equation. So 6x minus 6x is 0x. That means the x term is gone. 5y minus 6y is negative 1y. And 32 minus 84 is negative 52. Then to get just y, what you have to do is divide both sides by negative 1, and you get y equals 52. So that's the y value of your point of intersection. Now what you do is you're going to take that y equals 52 and you're going to substitute it into either one of the equations. You can substitute it into equation 1 or you can substitute it into equation 2, whichever one you prefer. Probably substituting it into equation 2 would be easier because there are less numbers to work with. So we're going to substitute that into equation 2 and then solve for x. So equation 2 was x plus y equals 14. So that's going to become x plus 52 equals 14. And then if you subtract 52 from both sides, you get x equals negative 38. So that's your x value. So your solution is x is negative 38 and y is 52. And just like last time, you can check your solution by substituting the x and y value into the other equation. The other equation was 6x plus 5y equals 32. So 6x plus 5y was on the left side, 32 was on the right side. So let's substitute 6 times negative 38 plus 5 times 52. Using your calculator will give you 32. So left side equals right side. So that tells you that that is the correct solution. So that's your first example. Let's go through it again. Try another example together. So again, we have our two equations in the same format. The x and the y's are on the left, the constant is in the right. And again, pick either x or y. It doesn't really matter which one you do. Let's do y this time. What we want to do is make the numbers exactly the same. So this is a 3 and this is a 2. Don't worry about the negative. We just have 3 and 2. So we'll label our equations 1 and 2. And we need to find the lowest common multiple of 3 and 2. The multiples of 3 are 3, 6, 9, etc. The multiples of 2 are 2, 4, 6, 8, etc. So the lowest multiple is 6. Now you don't have to do this work. You can do that work in your head. You don't have to write it out. It really doesn't matter. So the lowest common multiple of the y values is 6. So what do you have to multiply equation 1 by to get 6 for the y's? You'd have to multiply it by 2. What would you have to multiply the second equation to get that to be 6y? You'd multiply it by 3. So multiply equation 1 by 2 and multiply equation 2 by 3. So once again, remember that all parts of the equation must be multiplied. So equation 1 becomes 8x plus 6y equals 6. And equation 2 becomes 9x minus 6y equals negative 57. Now you can see we have made the y coefficients the same, the difference here is that one is positive and one is negative. So in order to get 0y, you will have to add the equations to eliminate the y value. Because then positive 6y plus negative 6y will give you 0y. So when you add those two equations together, you will get 17x equals negative 51. Divide both sides by 17. And that leaves you with x equals negative 3. Now we're going to substitute that x equals negative 3, and we're going to substitute it into either one of the equations, number 1 or number 2. So let's substitute it into number 1. And we're going to solve for y. So the equation was 4x plus 3y equals 3. So x is going to be negative 3. So 4 times negative 3 plus 3y equals 3. 4 times negative 3 is negative 12. And to solve this equation, add 12 to both sides. And that will give you 3y equals 15. And divide both sides by 3 to give you y equals 5. So the point of intersection, or the solution, your x value is negative 3 and your y value is 5. So always remember that the x comes first and the y comes second, because sometimes you solve for y first and x second, but you want to make sure you put the x first here and the y second there. Now step 8 says that you have to check your work in both equations. You do not have to check your work in both equations. Since you already figured out the y value using equation 1, that means you only need to check your work in equation 2. So equation 2 was 3x minus 2y on the left side and negative 19 on the right side. So to substitute our values in, x was equal to negative 3 and y was equal to 5, and that gives you negative 9 minus 10, which is negative 19. So left side equals right side. So our point of intersection, or our solution, is correct. So just remember, if you used equation 1 to solve for y, then you only need to check your answer in the other equation, which is equation 2. And then once again, it's up to you whether you eliminate the x's or eliminate the y's first. And remember, if your symbols are the same, or if the signs are the same, you subtract. If they're different, you add. Now press pause on the video, try this example on your own, and then come back to the video to check your answer. Press pause now, please. If you're ever having trouble deciding what to multiply each equation by, take a look at the x's, multiply equation 1 by the coefficient of the x value in equation 2, multiply equation 2 by the coefficient of x in equation 1. They'll both equal 20x, and you'll be able to cancel them out. That way will always work if you're ever having difficulty doing that very first step. If you need any help, make note of what you need help with and ask your teacher tomorrow.